Hello Internet, I am McTiger Raphael, and today we will be going over SNAYKEE, which is a game that I made. I worked on this game on and off for a few months on the side, and finally completed it like a couple days ago, like 3 days ago. I created this game using C++ and SFML. C++ was used for the core logic and system architecture, and SFML was used for graphics rendering, input, and audio. I'm going to start the video off with some development details, just a few things I'm going to highlight. I'll try not to get too technical, and then in the end of the video, towards the end of the video, I will just be doing the gameplay. So for those who just want to see gameplay, I'll either add a timestamp to the screen or in the description, and you could just skip to that portion of the video for the gameplay. For those who want like a more technical deep dive or more technical details, that will be up on the portfolio page, which I will also be putting in the description. Without further ado, let's get started. First, we have a save load system, which is used to save player high score and your favorite spacecraft. So you don't have to select it every time you open the game. It will save whichever one you have selected, and whenever you start again, it will automatically be selected for you. Next, we have different screens or states. So I have controls, credits, and this basically was done using a state management system for these different screens and stuff. And that basically uses a stack data structure to have the different states, and whenever you want to switch states, you can just pop them off the stack if you want to completely remove them, or you can point to a different state that is already on the stack. And that's how I handled the state management, and well, for the screens at least. For the premise of the game, you are a spaceship pilot in space, and you're piloting your spacecraft, and you are trying to get as far as possible without, I guess, dying. So bottom right, you have your energy, which is constantly going down, and the way to replenish your energy is by collecting stars, which replenish your energy. There are 3 different types of stars, each one providing a different amount of energy back to the spacecraft. So like if I get this one, it's a certain amount, and if I get this one up here, it's a different amount, and this one is the most. You also have asteroids coming down that you must avoid. If you get hit, it does take a decent chunk out of your spacecraft's energy, so you must maneuver your way around. You can also shoot these laser shots, and they do destroy asteroids. So if you're in like a position to where you might be trapped, you can shoot an asteroid, destroy it, and then maneuver to a more favorable position. However, these laser shots do cost energy, so don't want to use them all willy-nilly. Should be wise with how you use them, because they do cost energy. Even though it's not a lot of energy, it does cost energy nonetheless. I'm pretty low on energy. I'm about to die here. On the bottom left hand side of the screen over here, you have the score, which is based on how long you survive as well as how many stars you collect. So once I collect this star, I get a boost up in energy, and also I collect this over here, I get a boost of energy, as well as a boost in my score. All right, back to the home screen. For these asteroids at the top, I am using object pooling, and basically the reason for doing that is to, well, for one, it saves on performance because you're not constantly creating or instantiating objects and constantly destroying objects. So you just have a pool of a certain amount of objects to work with, and basically whenever you need one to use, you just pick it from that pool if it's not already being used, and you just use that. So saves on performance, saves on speed, also saves on memory because you're not constantly allocating memory for these objects and constantly deallocating memory. You just have that one pool you're working with. You just have to instantiate those objects once and then work with what you have. I'm also using object pooling for these laser shots. Actually, I guess we could take a look at some code. Let's get into some code here. So, for example, let me pull it up. So I have this obstacles class. So this is the obstacle object, and then I have a struct that holds instance of said object and also a boolean which keeps track of whether it's being used or not. And whenever it is time to let's say, and let's go here. Let's say it's time to generate an asteroid. We'll loop through the vector or the list or the pool, and then check to see if it's currently being used. If it's not currently being used, set its flag to true. So now it is being used, and then call this reset function, and then pass a couple of values. And this is basically how you reset it to be used. Pass in a position, size, position, speed, with how fast it's falling down, determine the texture you want to use for it, and yeah, that's basically how it resets it. I'm also using object pooling for the sounds. Basically have a pool of sound buffers, and whenever I need to play something, check to see if, basically check for any of those buffers that aren't being used, and then use that buffer to play the sound. Using procedural generation to generate these asteroids. Also using procedural generation to generate these stars. So every time you run through this, it'll be a different experience. Like it's never gonna always be the same asteroids, always in the same positions. So it's a different experience each time. So up here is how I'm generating the obstacles, making use of my custom math library, which is still in the works. It's not completed yet, but basically doing some basic calculations on where to spawn it, choosing random, basically giving it a window or a range, and then randomly picking between that range, doing that for the size as well as the position and the speed, and check the pool to see which ones aren't being used, and start using it. Hitbox, as you can see, you have this little option here for hitbox. The game does use like this basic bounding box collisions, so sometimes the collision isn't the best. This is beneficial because you can actually see the hitbox, which helps you like maneuver around, more precise maneuvering. Because the last thing I kind of might want to just point out is this right here, which is the game context. Basically using this as a way to, well, it's used to hold all the major systems in the game. So asset manager, audio manager, game manager. And basically whenever a class needs to use or needs to access any of these systems, it could just access the game context and be able to use those. Like for example, whenever the game starts, I create a game context here, boom, and then whenever you create the states, each state, upon creation, it requires the game context. So even like this game state right here, and this constructor requires game context, and basically it uses that whenever it needs to access, for example, asset manager, in order to use an asset to draw to the screen, or what else, like access the window. Actually, let me see here. I'll just do this so you can see where it's being used. So yeah, accessing the asset manager, accessing the window for certain calculations, um, as well as accessing the audio manager if it needs to play a certain sound. Yeah, and that is it. Well, obviously, there's a lot more that went into this project, but those are the things that I wanted to highlight, the things that I had the most fun implementing. Um, and yeah, thank you for watching. Hope you guys have a wonderful day. Uh, Stay safe. Now it is time for the gameplay portion. Just gonna do one run through. Try to beat. I guess I'll try to beat my high score down here. Um, yeah, let's get it started. Whoops, my mic was muted. But yes, there you have it. One full playthrough. Ended up beating my high score. I was kind of sweating a little bit, but yeah. Thank you for watching the video. Again, hope you guys have a wonderful day and stay safe out there. Thank you.